Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The compound is 1,3,5-trimethylcyclohexane. Step 1. Identify stereocenters. C1, C3 and C5 each bear a methyl group and are stereocenters. Each carbon is attached to two different ring portions and a methyl group versus H. Step 2. Maximum possible stereoisomers is equal to 2n is equal to 3 is equal to 8, but symmetry reduces this number. Step 3. Analyze the symmetry. The molecule has a plane of symmetry through C1 or through the ring depending on configuration. The three stereocenters at C1, C3, C5 are related by the molecular symmetry, C3V symmetry of the ring positions. Step 4. Enumerate distinct stereoisomers. The possible combinations are I, all three methyls on the same phase, all CIs to each other, 1 alpha, 3 alpha, 5 alpha. This is the all CIs isomer, which has a plane of symmetry, making it achiral, mesylite. 2 methyls on one face and one on the other. Example, 1 alpha, 3 alpha, 5 beta. Due to the symmetry of the 1, 3, 5 positions, all arrangements with 2 on one face and 1 on the other are equivalent, but we need to check chirality. The 1 alpha, 3 alpha, 5 beta isomer and 1 alpha, 3 beta, 5 alpha and 1 beta, 3 alpha, 5 alpha are all related by the C3 symmetry and are the same compound. Similarly, 1 alpha, 3 beta, 5 beta and its permutations are all the same compound. So the distinct stereoisomers are A. All up, 1 alpha, 3 alpha, 5 alpha, achiral, B. All down, 1 beta, 3 beta, 5 beta, achiral, and these two are actually mirror images of each other, since the molecule with all three up has a plane of symmetry, C3V, it is achiral and identical to its mirror image. Weight re-examining, 1 alpha, 3 alpha, 5 alpha, has C3V symmetry and is achiral, same as its mirror image all beta which is also achiral. These two are the same compound, superimposable. So that gives one achiral compound. C. 1 alpha, 3 alpha, 5 beta 2 up, 1 down. This isomer has a plane of symmetry through C5 and the midpoint of C2, C4 bond, making it achiral. D. There is no other distinct arrangement. So total distinct stereoisomers, the all same, CIS, isomer, achiral, and the 2 up 1 down isomer, achiral, is equal to 2 stereoisomers total. The all CIS, all on same phase, is one compound, and the 1, 3 CIS, 5 trans, 2 on one face, 1 on other, is another compound. Both are achiral due to internal planes of symmetry. Thus total stereoisomers is equal to 2. Therefore, the correct answer is A. Therefore, the correct answer is option A.